All right. Hi, guys. Today we're going to do section 15.7, and it's about curve fitting. Today is the last lesson of the chapter. Whoop, whoop. Yeah. And then we'll review tomorrow and then your group quiz on Friday. So you do need your graphing calculator today. So get out your graphing calculators, or saddle up next to someone who has a graphing calculator so that you can watch. All of the directions are on the page, and so you definitely want to practice doing this. Okay? All right, let's do it. Curve fitting. You've got your fill-in notes to make it easier. And here we go. So with statistical applications, exact relationships may not exist. Often what that word was, but okay. Often, an average relationship is used instead. And so we've got things called regression analysis, and it is a collection of methods by which estimates are made between two variables. So regression analysis, it's a collection of methods by which estimates I don't even know. A collection of methods by which estimates are made between two variables. We've got correlation analysis, which tells us the degree to which the variables are related. Correlation. And we've got a scatter plot, which is a good tool for recognizing and analyzing relationships. So regression analysis, you probably don't remember this, but back when we did the M&M project where you cut out that index card and did the corners and made your little open top box, and then you plotted all of the data from everybody's collected, counted how many M&Ms fit in their boxes depending on the size, and then you put in your graphing calculator all of the dimensions of the boxes and then how many M&Ms fit, and then we put in our graphing calculator and we were able to get an equation. That was a regression analysis. That's what we're actually going to do today. On a whole bunch of stuff. All right, so here you've got this on your paper. The independent variable is your x-axis and the dependent variable is on the y-axis. Your dependent variable is the prediction to be made, and the independent variable is your basis for the prediction. Going back, there we go. So independent variable is the variable that goes on the horizontal or x-axis, and it's your basis for your prediction. The dependent variable depends on the independent variable, and it's your prediction that you want to make. All right, you should raise your hand right now if you need the sub to pause the video. If you are still writing all of this down, raise your hand so they can pause it. Otherwise, let's go to the first example. So example 1 says a college admissions committee wishes to predict students' first-year math averages from their math SAT scores. And then they plotted the data. And so notice that along the x-axis or horizontal axis, they've got the SAT scores, and then on the y-axis is the grade. So remember, they wanted to predict the first-year grades from their math SAT scores. And you see all these points. And so notice that these points are not on a clear straight line, right? So it's not an exact relationship is what that means, but it can still tell us something. And there's two things that we can summarize from this. So one thing that we can summarize is that in general, higher SAT scores do correspond to higher grades. The fact that the higher your SAT scores, the higher the grade, or at least that looked like the overall trend anyway, we can summarize that in general, higher SAT scores correspond to higher grades. And the other thing we can conclude is that this definitely looks like a positive linear. I know it's not a straight line, but you can kind of see that it doesn't look curvy or anything. Or it's a direct relationship. So it's positive, meaning because as SAT scores go up, so do grades. So if you remember, direct variation. So our graphing calculator can plot scatter plots. You do need to remember to identify which variable is the independent one and which one is the dependent one. And then once we have a scatter plot, we identify the line or curve that best fits the points. That's what we did with the M&M project when you came up with the equation. So here's some examples of some scatter plots and how they're related. The top one, has a direct linear relationship. In fact, all of those points are just really writing a straight line like that. The second one is an inverse linear. It still looks like pretty close to a straight line there, but as the x values increase, the y values are decreasing. That's why it's inverse. We've got curvilinear, is what your book calls it, when that one looks almost like not quite like a quadratic, but it's definitely curvy. The bottom left-hand corner one, direct curvilinear, is a little curvier than a straight line. Anyway, your graphing calculator will use exponential for that one. That's what we'll do for that one. Second row in the middle, inverse curvilinear, because as x is increasing, then your y is decreasing, but it's not like a straight line. It still is kind of sort of curvy. And then the last one in the bottom corner, there's absolutely no relationship between those points. You notice that they are dotted all over the place. So that was just an overview. Statisticians use the method of least squares to obtain a linear regression equation. You've got that, if you remember, y equals mx plus b is what you're used to seeing. This time we're going to write it as y equals a plus bx, where a is your constant, b is the slope. I don't know, can they make it more confusing? You know, you can curse out the old dudes too. I get it. You got this little graph of how it works. And so in this thing, the sum of all of the values of the delta y, so the change in y, the distance from the actual plot or the point to this linear regression equation, all of these little delta y's will add up to 0. And the sum of the squares of the values of delta y, they want that to be as small as possible. So those are your two little bullet points that you're writing there. That the sum of all the values of the delta y's will equal 0, which if you look at the picture, it should make sense. You've got 4 points above the line. You've got 3 points below the line, but if you look at the points above the line have a little bit shorter distance than the ones that are below the line. So if you were to add them all up, they would equal 0. And then the sum of the squares, if we squared each of these values and then added them together, we want that value as small as possible. Luckily, this is in your handout notes, so you don't have to write this, but we want to do this to our calculator right now, so that way it'll give us the regression line. It's possible that you did this already back when we did the M&M project, but if you reset your calculator at all, it would have reset it. So on your calculator, what you want to do is we want to turn the diagnostics on, because that will give us it's going to give us some information that we want to know about this. So on your calculator, you want to hit the second button, and then the 0. If you notice, right above the 0 in blue writing is catalog, and that's what we want to bring up, is catalog. And then what you want to do is scroll down to the D's. You can also hit second 0, alpha, where's D? If you hit alpha and then the little X inverse button, it'll bring you all the way down to the D's. Then you still have to scroll down to diagnostic on, and then you want to hit enter to bring up diagnostic on, and then hit enter again, and it'll give you that it's done. I don't know if will it show up on here. Yeah, something like that. You want it to actually say that it did it. Wrong way, this way. All right, so diagnostics are on, and we can do this next example. So it says a runner's stride rate is dependent on his or her speed, and so they give you this table, and we're going to plot it using a scatter plot. And how you do that is you're going to hit the stat button. The stat button is, if I can, no, this way. Stat button is right, this one right there. No, I gotta go backwards that way. So there's your stat button. So you want to hit stat and then edit. So just hit enter for edit. And under L1, you're going to enter in the speed, which was our independent variable. So you want to enter each of the values, the 15.86 under L1, 16.88, and hit enter in between each of them. Give you a chance to put that in. So put all of, you can hit enter, it'll scroll down. And then you want to arrow over to L2, and under L2 you want to put in all of the data for the stride rate. So the 3.05, 3.12. You do want to make sure that for each, speed that it is matching up with the correct stride rate. Should look like that once you got all of those entered in. All right, then what you're going to do is you're going to hit the second button and then Y equals. Those are the two left-hand corner. They're over here, right? Second is the blue button, then Y equals to bring up stat plot. And then you just want to hit, with the one highlighted, you want to hit enter. And then you want to end up seeing this. You want it to show on. You want the first type to be highlighted. You want under X list to say L1. You want Y list to show L2. And then the mark I want is the little square thing. I have the newer calculator, so it also lets me choose a color. I'm just leaving it blue. And then you want to hit window and enter in all of these values for Xmin to be 0, Xmax 25, Xscale 5, 0, 4, and 1. And then when you get done with all of that, then you want to hit graph. And you should get that. I'll go back so that way, well, no, you guys have it on your little handout. Okay, so that is what you should end up getting. Something like that, looks like that. All right, so what does it look like? Definitely looks pretty linear to me, right? Looks like a direct linear relationship. It's a pretty close line. Looks pretty straight, you know? So let's double check it. Let's have our calculator do a linear regression for us. Let's have him the calculator figure out what is the line of best fit for this data. So to do a linear regression, this is also on your handout, you'll hit Stat again, that's the one next to the arrows, and this time you want to arrow to the right to highlight Calc, and then because it looked like a line, then we're going to do the linear regression. We're going to do the number 8 one. I know there's a number 4 there. I think your book has all the answers listed doing number 8, I think is why we do that one instead. Honestly, I don't remember. Whatever, we're going to do number 8. Do linear regression, a plus bx. Under x list, you want to make sure L1 is there. Under y list, you want to make sure L2 is there. And then you want to arrow down to calculate and hit enter. And it should give you this information. Y equals a plus bx is the form of the equation. A is 1.766 and b is 0.0802. And so putting that in the form y equals a plus bx gives you your equation. So that's the equation of this line. And then what is r? This is what, by turning on the diagnostics on before, if you didn't turn diagnostics on, it won't give you r squared and r. So if it's not showing up, it's because your diagnostics are not on. But what is r? R is what we call the correlation coefficient. And what it does is it tells us how good our regression model fits the data there. The closer that r is to 1, if it's a direct linear, or if it's, even if it's almost a -1, if this had been an r equals negative 0.9989, that's almost -1. That just means that it's an inverse linear. But the closer that number is to 1, the better that our model, this equation, fits the data. So the fact that we got an r of 0.998898, like, that is a fabulous correlation. And so our equation, if we were to use all those decimal places, really, is a great model or equation for this data that we got. So here's an example, it's on your paper, of 3 scatter plots of what correlation coefficient would give you. On the first one, and you notice that they are totally in a straight line with a positive slope. That would be an r equals 1. If you have a completely straight line, they're all going to fit on an exact line, but it's got a decrease in slope, then r would be -1, that correlation coefficient. And if they're all over the place, they have no relationship whatsoever, you'll get an r equals 0. All right, so let's move on to the next example. So let's match these scatter diagrams with the correlation coefficients. So we've got 3 different scatter plots there, and we want to match up which one do you think is r equals 0.3, which one do you think would be r equals 0.9, which one would be r equals -0.4, and then which one would be r equals a -0.75. I'll give you like, I'll set my timer. Try to figure out on your own real quick. Do this one on your own. See if you can see what you think. Which one do you think it should be? For each of them. All right, hopefully that was enough time for you to kind of think about it a little bit. Here are what the actual correlation coefficients are. The first one is 0.9. So I know it's not an exact line, they're a little bit off, but 0.3 is this way too low of a number for that to match up with that. Like that, it's definitely, they're definitely closer to on a line, closer, anyway, definitely better correlated than a 0.3. And you can't do the negatives because it definitely is a positive relationship. And so it's either 0.3 or 0.9, and 0.9 definitely matches it better. Rising line, the points fit well. They're not exact, but that's okay. A 0.9, if you got an R of 0.90, it's not that great of a fit. It's not horrible, but it's not great. 0.98, 0.99, that's good, but 0.90 isn't fabulous, so 0.9. This second one is a negative 0.4. It is a falling line, so it's definitely negative. So between negative 0.4 and negative 0.75, I know it's not super easy, but there's a lot of points that are not on, you know, what I would consider like the line of best fit right through there. There's a lot of them that are kind of scattered about. So negative 0.4, they're not very closely related. And then the last one, it definitely looks like it's a positive slope. It's a rising line, but they are all over the place. And so that is a 0.3. So it fits the points, but not super close. And then we have on there that a straight line is not always the best way to describe a relationship. The relationship may be described as curvilinear. Right? So not always is a straight one. And in fact, we gave you those pictures in the beginning of different types. So your graphing calculator has an exponential regression function. So if it looks like, I pointed that out to you, that when it was the curvilinear, like the direct curvilinear, like that would be like an exponential regression line. We've got, we could have a logarithmic line. That'll be, you'll see that in your graphing calculator as natural log regression. And then we also have a power regression, which would be like an x squared or an x cubed or an x to the fourth type of a thing. I'll give you a chance to write those down. That's what's going in the little box. And all of these can be found under the stat menu on your calculator. So you'll go stat and then calc. And we found the linear regression one there. We're going to be able to find exponential regression, logarithmic, and power regression in the same spot. All right, so raise your hand if you need the sub to pause the video at this point so you can continue to finish writing down. Have them pause it if you need them to. Let them know. And if not, well, let's move on. Last example. Yes. So an accountant presents the data in the table about a company's profits in thousands of dollars for 7 years after a management reorganization. So let's do the scatter plot. You're going to hit stat and then 1 for edit, and you're going to enter the data in L1 and L2. So stat, enter for edit. If you arrow up, because you've got all that information from L1 and L2 from the last problem, if you arrow up and highlight L2 and clear it, and then arrow back down, it'll clear the entire column. Same thing for L1. If you hit clear and then arrow down, it'll clear the entire column. So under L1, you want to do 1, 2, 3, 4, 5, 6, 8, 7. And under L2, make sure you match them up. It was year 1 was 150, year 2 is 210. All right, so you enter in those and then hit window and enter in that information. And then hit graph. And I got a graph that looks like this. So it definitely does not look like a straight line this time. It looks more exponential to me. It looks like it's curving up, right? So let's try an exponential regression. So you want to do stat and then calc. So arrow to the right to hit calc. And then exponential regression is 0. Expreg. And you want to make sure L1 and L2 are under your X list and Y list, and arrow down to calculate it. And it shows you Y equals A times B to the X, where A is 107.20. I don't know why I didn't round. I got 2085, and then anyway, left it at 208. And then B is 1.438, but I rounded that one. Don't know, but that's okay. And I also got, did I put it on here? No. Okay, look how good of it is a good predictor, right? I got my correlation coefficient is 0.99685. 0.996 that's a good correlation coefficient. So we did well in choosing an exponential regression instead of a linear regression because it fit the data well. And so now we're going to use this model to predict the profit for year 8. And to do that, you're predicting the profit. Profit was Y, X was your year. And so for year 8, you're going to plug in an 8 into X. So you'll go 107.208 times 1.439. We're raising it to the 8th power. My calculator gives me 1971.1. Remember though that the problem says that the profit is in thousands of dollars. So that means it's 1,971,000. And so that means the profit, ooh, I want to join this company. Profit is 1,971,000. All right. I think that's it. Next slide is your homework. Hopefully all of that made sense. And here's your homework. Page 842, those problems. What we want you to do is go ahead and use your graphing calculator for all the scatter plots, and then just make a sketch of what your calculator gives you. All right, so use your graphing calculator for all the scatter plots, and then just on your homework, write a little sketch of what your calculator gives. All right, guys. I hope you had a fabulous day, and I will see you soon.